Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few problems on the topic chain rule so that you can have a better understanding of the concept. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. These questions are the ones where marks can be scored easily if practiced well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. 10 men working 6 hours a day can complete a work in 18 days. How many hours a day must 15 men work to complete the same work in 12 days? You are given 4 options here and you have to find out which of these options is the correct one. Now here the work done is the same. So use the formula P1 D1 H1 is equal to P2 D2 H2. Now here P1 the number of persons is 10, D1 the number of days is 18 and H1 the number of hours is 6. Also P2 the number of persons is 15, D2 the number of days is 12 and we have to find out H2 the number of hours. So substituting all these values in the formula here, we have 10 multiplied by 18 multiplied by 6 is equal to 15 multiplied by 12 multiplied by H2. So H2 is equal to 10 multiplied by 18 multiplied by 6 divided by 15 multiplied by 12. On solving this, we get H2 is equal to 6 hours. So 15 men must work for 6 hours a day for 12 days to complete the work. So the correct answer is option C, 6 hours. 20 men or 24 women can complete a piece of work in 20 days. If 30 men and 12 women undertake to complete the work, in how many days will the work be completed? You are given 4 options here and you have to find out which of these options is the correct one. Now it's given that 20 men or 24 women can complete a piece of work in 20 days. So this means that 20 men are equivalent to 24 women. If we divide both these numbers with 4, we get 5 men are equivalent to 6 women. Now it's given that 30 men and 12 women undertake to complete the work. Now we know that 6 women are equivalent to 5 men. So 12 women will be equivalent to 10 men. So 30 men plus 12 women means 30 men plus 10 men, which is nothing but 40 men. Now since the work done is the same, use the formula P1 D1 is equal to P2 D2. Here P1 the number of persons is 20 men and D1 the number of days is 20 days. P2 the number of men is 40 men and we are supposed to find D2 the number of days. So substituting all these values in this formula here, we get 20 multiplied by 20 is equal to 40 multiplied by D2. So D2 is equal to 20 multiplied by 20 divided by 40, which is nothing but 10. So the work will be completed in 10 days. The correct answer is option C, 10 days. A fort had provision of food for 150 men for 45 days. After 10 days, 25 men left the fort. Then for how many days will the remaining food last? You're given 4 options here and you have to find out which of these options is the correct one. Now it's given that a fort had provision of food for 150 men for 45 days and after 10 days 25 men left the fort. Now, if after 10 days the 25 men had not left the fort, then these 150 men would have had provision that would have lasted for another 35 days. But since it's given that 25 men left after 10 days, now there are only 125 men left in the fort. So now we have to find out for how many days the provision would last for these 125 men. Now, since the amount of provision is the same in both these cases, use the formula P1D1 is equal to P2D2. Here, P1, the number of persons is 150 men, and D1, the number of days is 35 days. P2, the number of men is 125 men, and D2, the number of days we have to find out. So substituting all these values in the formula here, we get 150 multiplied by 35 is equal to 125 multiplied by D2. So D2 is equal to 150 multiplied by 35 divided by 125. On solving this, we get D2 as 42 days. So the remaining food will last for 42 days. The correct answer is option C, 42. X number of men can finish a piece of work in 30 days. If there were 6 men more, the work could be finished in 10 days less. What is the original number of men? You are given 4 options here and you have to find out which of these options is the correct one. Now, since here the work done is the same in both the cases, use the formula P1D1 is equal to P2D2. Here, P1, the number of men originally is X. D1, the number of days is given as 30. Now it's given that if there were 6 men more, that is P2, the number of men would be 6, X plus 6. The work could be completed in 10 days less. So D2, the number of days would be 30 minus 10, that is 20. So P1 is X, D1 is 30. P2 is X plus 6 and D2 is 20. Substituting all these values in the formula here, we get X multiplied by 30 is equal to X plus 6 multiplied by 20. On solving this, we get X is equal to 12. So originally there were 12 men. The correct answer is option B, 12. Some carpenters promised to do a job in 9 days, but 5 of them were absent and the remaining men did the job in 12 days. What was the original number of carpenters? You're given 4 options here and you have to find out which of these options is the correct one. Now, since the work done in both the cases is the same, use the formula P1D1 is equal to P2D2. It's given that some carpenters promise to do a job in 9 days, but we do not know the original number of carpenters. So let's assume that the original number of carpenters is X. So P1, the original number of carpenters is X, and D1, the number of days is 9. Now it's given that 5 of them were absent. So now the number of carpenters P2 is X minus 5. And it's given that these men did the job in 12 days. So D2, the number of days is 12. Now substituting all these values in this formula here, we get X multiplied by 9 is equal to X minus 5 multiplied by 12. On solving this, we get X is equal to 20. So originally there were 20 carpenters. The correct answer is option D, 20. 7 men can complete a piece of work in 12 days. How many additional men will be required to complete double the work in 8 days. You are given 4 options here and you have to find out which of these options is the correct one. Now, as you can see here, the amount of work done in both the cases is different. In the first case, it is a piece of work, and in the second case, it is double the work. Since the amount of work done in both the cases is different, use the formula P1 D1 divided by W1 is equal to P2 D2 divided by W2. Here, P1 is given P1, the number of men is given as 7. D1, the number of days is given as 12. W1, the amount of work is given as 1. In the second case, D2, the number of days is given as 8, and W2 is double the work. So if in the first case the work was 1, then double the work will be 2. So W2 is 2. Now P2, the number of men required to complete double the work in 8 days, is not known. So first we'll find out P2. Now substituting all these values in the formula here, we get 7 multiplied by 12 divided by 1 is equal to P2 multiplied by 8 divided by 2. On cross multiplication, we get P2 is equal to 7 multiplied by 12 multiplied by 2 divided by 8. On solving this, we get P2 is equal to 21. That is, 21 men are required to complete double the work in 8 days. But originally there were only 7 men. So the number of additional men required is equal to 21 minus 7, which is 14. So 14 additional men will be required to complete double the work in 8 days. The correct answer is option B, 14. A man undertakes to do a certain work in 150 days. He employs 200 men. He finds that only a quarter of the work is done in 50 days. How many additional men should be appointed so that the whole work will be finished in time? You are given 4 options here and you have to find out which of these options is the correct one. Now it's given that a man undertakes to do a certain work in 150 days. He employs 200 men, but he finds that only a quarter of the work is done in 50 days. So the remaining 3/4 of the work should be completed in 150 minus 50, that is 100 days. Now, as you can see here, the amount of work done in both the cases is different. Here it is quarter of the work and here it is 3/4 of the work. Since the amount of work done in both the cases is different, use the formula P1 D1 divided by W1 is equal to P2 D2 divided by W2. Now here P1 is the P1, the number of men is 200. D1, the number of days is 50. And W1, the amount of work done is 1 by 4. Now D2, the number of days is 100. W2, the amount of work done is 3 by 4. And we have to find out P2, the number of men who can do the remaining 3/4 of the work in 100 days. So substituting all these values in the formula here, we get 200 multiplied by 50 divided by 1 by 4 is equal to P2 multiplied by 100 divided by 3 by 4. This 4 and this 4 will cancel out And on cross multiplication, we get P2 is equal to 200 multiplied by 50 multiplied by 3 divided by 100. On solving this, we get P2 is 300. So 300 men can complete the remaining 3/4 of the work in 100 days. But originally there were only 200 men. So the number of additional men to be appointed is 300 minus 200, which is 100. So 100 additional men should be appointed so that the whole work will be finished in time. The correct answer is option D, 100. If 72 men can build a wall of 280 meters length in 21 days, how many men could take 18 days to build a similar type of wall of length 100 meters? You are given four options here and you have to find out which of these options is the correct one. Now, as you can see here, in the first case, the length of the wall to be built is 280 meters. In the second case, the length of the wall built is 100 meters. As you can see, the amount of work done in the first and the second cases is different. So since the amount of work done is different, use the formula P1 D1 divided by W1 is equal to P2 D2 divided by W2. Now here P1 the number of men is 72, D1 the number of days is 21 and W1 the amount of work is 280. D2 the number of days is 18. W2 the amount of work is 100 and P2 the number of men who could build a wall of length 100 meters in 18 days is to be found out. Now substituting all these values in the formula here, we get 72 multiplied by 21 divided by 280 is equal to P2 multiplied by 18 divided by 100. On cross multiplication, we get P2 is equal to 72 multiplied by 21 multiplied by 100 divided by 18 multiplied by 280. On solving this, we get P2 as 30. This means 30 men could take 18 days to build a wall of length 100 meters. So the correct answer is option C, 30. Running at the same constant rate, six identical machines can produce a total of 270 bottles per minute. At this rate, how many bottles could 10 such machines produce in 4 minutes? You are given four options here and you have to find out which of these options is the correct one. So as you can see, the number of bottles produced in the first case and the second case would be different. So the amount of work done is different. So use the formula P1 D1 divided by W1 is equal to P2 D2 divided by W2. Here P1 the number of machines is 6 and D1 the time is 1 minute and W1 the number of bottles produced is 270. P2 the number of machines is 10. D2 the time is 4 minutes and W2 the number of bottles that could be produced by 10 machines in 4 minutes is to be found out. Now substituting all these values in the formula here, we get 6 multiplied by 1 divided by 270 is equal to 10 multiplied by 4 divided by W2. On cross multiplication, we get W2 is equal to 10 multiplied by 4 multiplied by 270 divided by 6. On solving this, we get W2 as 1800. So 1800 bottles are produced by 10 machines in 4 minutes. The correct answer is option B, 1800. A man completes 5/8 of a job in 10 days. At this rate, how many more days will it take him to finish the job? You are given 4 options here and you have to find out which of these options is the correct one. It's given that work done in 10 days is 5 by 8. So remaining work is 1 minus 5 by 8, which is 3 by 8. Now let the number of days to complete the remaining work be D2. As you can see, the work done in both these cases is different. So use the formula D1 divided by W1 is equal to D2 divided by W2. Here D1 is 10, W1 is 5 by 8, D2 we have to calculate and W2 is 3 by 8. Substituting all these values in the formula, we get 10 divided by 5 by 8 is equal to D2 divided by 3 by 8. This 8 and 8 gets cancelled. On cross multiplication, we get D2 is equal to 10 multiplied by 3 divided by 5, which is 6 days. So 6 more days are required to finish the job. The correct answer is option B, 6. If the work done by x minus 1 men in x plus 1 days is to the work done by x plus 2 men in x minus 1 days in the ratio 9 is to 10, then what is the value of x? You are given 4 options here and you have to find out which of these options is the correct one. Now it's given that the ratio of the work done is 9 is to 10. From this it is clear that the work done in both the cases is different. So use this formula. P1 D1 divided by W1 is equal to P2 D2 divided by W2. So it's given that W1 divided by W2 is equal to 9 divided by 10. So now this formula can be rewritten as W1 divided by W2 is equal to P1 D1 divided by P2 D2. Now W1 divided by W2 is 9 by 10. P1 the number of men is x minus 1. D1 the number of days is x plus 1. P2 the number of men is x plus 2 and D2 the number of days is x minus 1. Substituting all these values in this formula we get 9 by 10 is equal to x minus 1 multiplied by x plus 1 divided by x plus 2 multiplied by x minus 1. This x minus 1 and x minus 1 gets cancelled. So we get 9 by 10 is equal to x plus 1 divided by x plus 2. On cross multiplication and solving, we get x is equal to 8. The correct answer is option A, 8. If 7 men working 7 hours a day for each of the 7 days produce 7 units of work, then how many units of work will be produced by 5 men working 5 hours a day for each of 5 days? You are given 4 options here and you have to find out which of these options is the correct one. Now as you can see here, the work done is different in both the cases. So use this formula. P1 D1 H1 divided by W1 is equal to P2 D2 H2 divided by W2. Here P1 is the number of men, which is 7. D1 the number of days is 7. H1 the number of hours is 7. And W1 the amount of work done is also 7. Now P2 the number of men is 5. D2 the number of days is 5 and H2 the number of hours is 5. And W2 we have to find out. So substituting all these values in the formula here we get 7 multiplied by 7 multiplied by 7 divided by 7 is equal to 5 multiplied by 5 multiplied by 5 divided by W2. On cross multiplication and solving, we get W2 is equal to 125 divided by 49. So 125 by 49 is the required units of work. The correct answer is option D, 125 by 49. Viewers, please go through this video till you have understood the concept. Practice more such problems to increase your speed and also to understand the concept clearly. Please do watch a video for solved problems on the concept of joining or leaving in the topic time and work. If you have liked this video, please like, subscribe and share this video. Thank you.